Alright, so here's going to be the review for the honors walkway number 6. Um, yeah, I hope as you go through this, you'll get a quick review over the stuff it covered, and that you'll be able to understand all the stuff you're supposed to do on your walkway. Here, on these first 3 here, you're writing down domain, range, and whether or not it's a function. Domain are the x values, range is the y values, and you list them from least to greatest, and don't put any repeats down. So if I look through my list here, I notice my lowest x value is -3, and then it goes up to -2, and then it goes up from there to 2, and then to 4, and then 5. Okay, notice how I got all these ones checked off, and -3 got used twice there. And so I only wrote it once on my domain there. The range starts out lowest value being 2, and it goes to 3, so 2's done, 3's done, the other 2's done, and it goes up to 6, and then we got 2 9's, but I'm only going to write it once, because you only write it once. Alright, so now we got all that. Is this going to be a function? It is not, because, oh wait, just kidding, what am I saying? This one is going to be a function, and that's even though this part here, which is where I got a little bit confused, it says -3 9 and then -3 9. So -3 got used twice, but it only got assigned one number each time. It was both 9, and so this one was going to be a function because I didn't get different y values for my input of -3. Okay. So be careful, more careful than I was, and make sure you know whether or not it's a function. This one, again, x values for your domain starts at -5, goes up to -3, -1, and then jumps up to 3, and then it goes to 5. The range, lowest value there is looking like 0, which is actually there twice. 1, 7, 8 is my range. Remember, those are the y values. Is this one going to be a function? Well, 1 only got assigned once. 3 got assigned, 2 different times though. 3, 1, and 3, 7. Okay, since 3 got assigned different values, it is not going to be a function because each input should only have one output. On 3, write down the domain, that's the x values. I notice it starts at -12 over here. It jumps up to -6, -3, and then jumps up to 2, which is there and there, and 5 is my last one. So there's my domain, time to get the range done, and the range is 3. Okay, notice how all of them, the answer is 3. At least the y value is always 3, so the range is only going to be 3. Is this going to be a function? Well, you have to look for repeats. I notice I do have a repeat here at 2, but 2 got assigned 3 both times, which means it is going to be a function. Okay, jumping over to the graphs here. Each one asking, not each one, on these first couple, 3, 4 of them, you're being asked, is it an increasing or decreasing function? Is the rate of change increasing, decreasing? And where's the interval where it's positive and negative? Okay, is this function increasing or decreasing? This one is decreasing because it's going down. Yeah, so there's your definition for you. Since the graph is going down as you go from left to right, it is decreasing. However, the rate of change, B here, the rate of change, that's the slope. So over here, my slope's pretty steep there. It's really negative. Think like -8 for my slope. But as I get over here, my slope goes really flat, like really close to 0. So let's say my slope is like -1/2. Well, my slope goes from -8 to -1/2. That's an increase. So this graph is the slope, the rate of change is increasing. even though the graph itself is decreasing. This function is positive everywhere, okay, from negative infinity to positive infinity, because with exponentials, they do not, they'll reach like a certain asymptote, which in this case is the x-axis, and they don't cross that line, and so it's never going to go negative. And so this function is negative nowhere. I'm just going to put it like nowhere. Or you could put like NA, because it's not applicable. It's never negative. But when you jump over this one, it does eventually become negative. And since I'm talking about, let's do it right now. Where is this one negative? Well, it starts being negative right there, which is at 5. And it goes on to infinity forever to the right side there. And you notice how negative talks about the y value, the up and down. Okay, your graph is below the x-axis there after when x is 5. Where is this function positive? Well, that's basically the rest of the graph, which is from negative infinity up until 5. So this one's going to be negative from negative infinity up to 5. You notice I put this circular bracket on 5, and that's because at 5 it is 0, which is not negative or positive. And since I'm moving up in my list here, I'm going to do B next. Is the rate of change increasing, decreasing, or constant? Well, kind of look over here, your rate of change is pretty level, so pretty close to 0. And as you get over here, your rate of change is more steep, the slope, and that is negative, so you can think like -6. Well, if you go from 0 to -6, that's a decrease, and so the rate of change is decreasing. And now let's answer A. Is this an increasing or decreasing function? Well, the function itself is going down, and so it is a decreasing function. 6. Let's do, is this an increasing or decreasing function? Since the function is going up, this one's going to be increasing. Is the rate of change increasing or decreasing or constant? Well, it starts out pretty level here, really close to 0, you know, like it has a slope of like 1/100th. But as you move to the right, it's getting more steep this way, and that'd be a positive slope because it's going up as you move right, and that's more of a slope of like 6. And so if you're going from like 1/100th to 6, that is an increasing rate of change. Where is the function positive? That's going to be from this point here, which is x is 2, and that's where my graph switches to be positive, and so it's going to be 2 to positive infinity, not including 2, the open bracket, because at 2, my function 0. Where is the function negative? Well, that's before 2, so from negative infinity up until 2. 7. Is this an increasing or decreasing function? Well, it's going down, and so this one's going to be decreasing. Is the rate of change increasing, decreasing, or constant? Well, if you jump over to 4, you notice it has a very similar shape. This one's just moved over this way, and it's more spread out. But the rate of change is doing the same thing, which is increasing from a negative, like -4, up to a really small negative, like -1/10. Okay. C. Where is the function positive? Well, it's positive from there forward. That's -6. So -6 to positive infinity. Wait, what am I doing? Yeah, that's where it's negative. So it's going to be negative to the right here, down below the y-axis, the x-axis. That's -6 to infinity, so that's the answer D. On C, though, that's basically all the way up until -6. So from negative infinity up to -6, that graph is positive. Jumping on now to the next one, 8. Here, what's the slope of the secant line from x equals -3 to x equals 2? Well, convenient enough, on yours, the point's already graphed for you. This point here is -3, 4, and then this point over here is the point 2, -2, and that's the 2 points that we need to get the slope between, and that gives us the slope of the secant. So to get slope, remember we have to do change in y over the change in x. And so I'm doing the y's subtracted, and then the x's subtracted, and -2 minus 4 gives me -6, 2 minus -3 is 5, so my slope of this secant is -6/5. The end behavior, jumping down to b, as x goes to -infinity, that means as you get on your function you head left along it, the y value continues to increase, but it doesn't pass this line here, which is at 7. So y goes to 7 there. Oh man, and I'm answering the wrong question. So that's the answer to double I there too, because I went left. So as x goes to -infinity. As x goes to positive infinity though, we're going to move right along our function, and it's going to decrease continually forever and ever and ever, and that's going to go down to -infinity. Jumping on to 9. Again, you're trying to get the slope of the secant between these 2 points there, where x is -1 and x is 4. And this point here, you have to have the whole point, because you need the y values to get the slope. That's the point, -1, 2. And then our right one here is the point 4, 8. So we're going to use those to get the slope. The change in y from 2 to 8 is 6. The change in x from -1 to 4 is 5. So my slope is 6/5. That just happened to work out to be the negative version of the previous one. Again, end behavior, hop on your graph. When you're doing to positive infinity, you head right. And since this graph is increasing forever and ever in the positive direction, going up, y is going to go to positive infinity. When you figure out the other one, you need to hop on your graph and head left, and that'll give you the end behavior as x goes to -infinity. Since this one levels out and doesn't actually cross 1, it's going to eventually reach 1, but at -infinity. Notice these are exponentials. Exponentials do have that behavior that they won't cross a certain number. Alright, moving on to our last 4 here. You're just evaluating, so take the number in the parentheses, put it in for the x of the appropriate function. So this first one, put in -2 in for this x here. You'll have -2 times 3 to the -2 plus 2. Remember, this has a negative here, and we have a negative there. The double negatives cancel, so that's going to give us 3 to the 2 plus 2 power, which is 4. 3 to the 4th power is 81, and when you times by -2, you're going to get -162. Next one, f at 0, so you're going to put 0 in for x. You're going to have 4 to the 0 power, which is 1, subtract 6, that's going to give you -5. Next one, you're going to put in for the f function, x equals 3, put 3 there, you got 4 to the 3rd power, which is 64, subtract 6, you're looking at 58. Wait, what am I? 64 minus 6, yeah, gives you 58, okay. And then the last one, put in 5 in for the x there, so you're going to get -2 times 3 to the -5 plus 2 power. -5 plus 2 is -3, so you get 3 to the -3rd. Whenever you have a negative exponent, you have to take that and put it under 1 with a positive exponent. So 1 over 3 to the third, that's the same thing as 3 to the negative third. And 3 to the third is 27, by the way. So you got negative 2 times 1 over 27. And when you do that, you get negative 2 over 27. Ta-da! All done.